Hello, Mr. Andy here. We're going to take a look at auxiliary view drawing today. In auxiliary view drawing, we've just left the unit on multi-view drawing where we show, say, a top, front, and right side view. In this part that you see up on your screen right now, the front view gives us, would give us this kind of look here. The right side view, however, would not properly show this circle for us because that circle is on a slanted surface. And if I were trying to produce a dimension drawing, which you'll do a little later on this semester, I can't place a 1-inch dimension on a slanted surface in a view because that view is foreshortened, as we would call it. It looks much shorter than it really is. So I would like to produce a view in my drawing that shows this surface, surface A, looking straight in at it, which requires us to do something besides project at 90 degrees, which is what we do in our multi-view or orthographic projection. So we're going to produce an auxiliary view for this particular part, and that requires some different drawing techniques. So let's go ahead and create this drawing in AutoCAD and take a look at how we get from our normal views to an auxiliary view in AutoCAD. All right. So I'm going to begin we'll begin with the right side view here. So I'm going to start in my drawing space. I have an inch template up already, and I'm going to go 2.8 inches over. That's the depth of the part. And I'm just going to box in. So I'm going to go up. My total height is 2.44, so I'm just going to go 2.44. I'll go back over 2.8, and hopefully that all lines up. So there's the beginning of the right side view, and let's go ahead and get these notches in. So they're 0.4 wide. So let's offset. O for offset, 0.4, and we'll just offset these in. The base is 0.4 tall, so I'll go ahead and take care of that while I'm at it. And now I can actually just do a bunch of fillets. So I'm going to just hit enter, and then I'm going to type F for fillet. My radius is set at 0 because I haven't set it at a number yet. And I should be able to pick these two lines, and then these two. And so it goes. I'm going to have to reconnect a line over here. The fillet command trimmed it away. And now I'll fill it again. Fillet is a real powerful tool if you make use of it. I need this corner up here. It's up 0.94 as we can see. So we'll offset, O for offset, 0.94. And we'll trim that off. Just TR for trim. And then the hole, I can't locate that because this surface here, if we look straight in at the part like we are here, this surface is slanting backwards away from me. And the circle is actually going to appear as an ellipse in this view. So I can't see that in its normal orientation here. I'm going to come back and get that in later, but right now I've got everything I can put in this view. I can't do any more. All right, now I'm going to draw my front view. So I'm going to offset a little more than usual. I'm going to go maybe 4 inches. My computer is lagging behind here. So offset 4 inches. Let's take that way over. Hopefully that will be enough. And I'm just going to start projecting. So I'm going to shoot that way across. And somehow I managed to get on the 0 layer. So let's fix that. All right. My view is 2.8 deep here, so my front view. So I'm going to offset 2.8. Get the depth of that view there. Let's fill it up a few corners here. There we go. I'll take this corner across, and let's trim that. And then this starts the slanted surface here. and it's at a 45, so I'm going to do a line. Straight up is 90 plus 45 is 135, so we're going to go angle 135. And up like so. Let's fillet that up, so I'm going to fillet. That's lovely. And let's take that line out of there. Now, it's 0.8 over to the corner, so let's offset 0.8. So that's the end of that line right there. And then we go downhill at 45, so we're going to do a line from here. We want to go 180, that's straight to the left, and then counterclockwise or plus another 45. So we want to go angle 225, like so. Whoops. Angle 225. Click that in. We'll fillet that corner. All right, we'll delete that. Okay, I have all the geometry I can produce at this moment in time here in the front view, and I'm ready to start my auxiliary view. Now, to do that, we're going to project from this slanted surface perpendicular to that surface out into space in this direction. And we're going to use a tool that's actually more used for drawing in 3D in AutoCAD to make this really easy to do. All right? So you'll get this in lecture, but here you go. I'm going to type UCS, okay? And that stands for User Coordinate System. And we can actually change the orientation of the coordinate system. Right now, X and Y are horizontal and vertical. I'm going to hit Enter. And you can see we have a whole bunch of options here for UCS. And we're only going to use two of these. We're going to use Object and World to get it back to where we were. So I'm going to type OB for object and hit enter, and I'm going to pick this slanted face that we want to project into that auxiliary view. And look at what's happened to my cursor now. Notice the grid, everything has rotated in space to be lined up with this face. Even the angles have changed, so 0 degrees, 90 degrees, etc. are now rotated into this orientation. Well, this works pretty nicely because now I can draw a line right from here and I can just project, and notice it snaps and it thinks that's 270 degrees, but we really don't care. Like so. So let's get a couple inches between views here. I'll offset 2 inches. Now, my depths in this view are equal to the depths in this view, but there is no way to project like with a miter line, like we did in orthographic projection. There's no way to project over here. Don't start trying to draw lines between these two views. It does not work, okay? It will dramatically change the depth of your part. So everything for depth has to just be the offset command. You cannot do any kind of projection to get depths. So again, we know this part is 0.28 or 2.8 deep, so I'm going to offset 2.8 and get the depth of that part. All right? Well, actually in this part, this is the very front corner when I'm in this view, so I'm going to pull that edge up there. Okay? And I'm going to do a fillet real quick just to square up that corner, so I know that's kind of the corners of the box that this view is going to fit in. The backmost corner, as I slide, look at the green line of my cursor. As I slide it down until it touches that view, this edge is the kind of the farthest up in this direction edge. So that's going to be the top of my view up there. So I'm going to take a line from here and I'm just going to pull it up some distance. And again, I'm just going to fillet. You don't really have to do this when you work with auxiliary views. I just want to get a box here. And I know that box is going to contain the view that I'm after. I don't know what it looks like yet, but I know that box is going to contain the view. All right, I have this corner projected. It's right here. And that separates this vertical surface from this angled surface. So let's deal with this vertical surface for a minute here. this portion of the vertical surface, if I come over here, is this wide, right? And this portion of that vertical surface is this wide. So I'm going to see two different widths in here. So let's deal with these are already here, right? But let's bring that corner up. I'm going to take a line right here. And that's where these corners here and here are going to be. And let's go over to the pictorial for a minute. That's where this corner and this corner are going to be. Okay, I'm going to end up seeing this shaped surface right here that we have. Then I offset in 0.4, so let's offset 0.4. Try that again. Offset 0.4. And I'm going to pull this back to there, like so. And I could trim this piece of line out. So let's trim. There we go. And now you can kind of see that inverted T-shaped surface. If you look over again at our pictorial drawing, I can see that inverted T-shaped surface. I'm going to just go ahead and pull this over a little closer. This T-shaped surface is right here. Now I have this 45-degree surface. This is going to be a normal surface in this view, and it ends at this corner right here. So let's take a line from this corner across to here, and let's fill it. No, let's not fill it. Let's trim that corner off. So this is that surface, and I know this corner right here, you can see where my mouse is. If I look here, that corner is this wide. It doesn't stick out over the feet. So I'm going to trim off between these two lines. I'm going to trim off this and this. Get that out of the way. While we're at it, I think we should trim this line off. There we go. It's looking better now. Starting to look like our auxiliary view. This little foreshortened surface here is the top. Again, let's get this back out of the way. It is this wide. So I should see it that wide. Notice the line doesn't keep going. That's what we want to see. Here's the back surface, and I know that back here, this back corner back here, that's this surface, this edge. This corner is only the width of this view in here, right? It's not the full width. So in spite of this corner that we see out here, it's not really there. So you really have to analyze when you work in auxiliary view. And if you look at a particular corner and look at where it is with relationship to my front view in this case, and then look over here, see how wide is that corner? How deep is it there? And that depth will be the same up here. Because it's really difficult to understand what's happening in these areas here, which right now are open-ended. But this leg that we see here that's sticking out, or this foot sticking out, it starts here, and I've got that line, and it ends right here. And I don't have that line, okay? So this ends right here. I'm going to take a line from here, and I'll go all the way through the part. And then let's trim and clip that down. And then these get clipped off, like so. And we'll take the middle out. And that's how those feet look when this part is, if you will, kind of tipped back, and we're looking straight at this front face. I will tell you this, if I drew a line from here, technically speaking, there's a hidden line through here. I'm not going to have you show it in class. Just clutters things up. Technically, that back corner is hiding back here as a hidden line, but we're not going to show that. Okay. Now I'm ready to draw the hole. So if we look over on our drawing, we see that it's 1 inch up and 1 inch over to get to the center point. And in this view, again, this rectangular surface is totally flat to my point of view right now. All these other surfaces are at angles. They're all, because we've tipped that part. You have to imagine, you have to try and visualize this thing rotated back, so we're looking straight in at this slanted face that we see here. So if we looked in this direction at this part, all these other things are at angles. So I'm going to offset 1 inch. And we said it's 1 inch over and 1 inch up to that center point, and I'm going to draw a circle right there with a diameter of 1.5. Okay. Now I'm going to delete these and show you one other cool thing about doing using the UCS command. And if you read the textbook, it tells you to use a rotated snap, but there's a couple things that don't work well, and one of them is this. One of the nice things about turning the UCS like this rather than using a rotated snap is that I can switch to the center layer and I can do a center mark of this circle, and it comes in aligned with the view. So do not, real quick, if I go back to UCS World, do not center mark an auxiliary view like that. That's absolutely wrong. Okay, the center mark has to align to the view. So don't show us that anytime that you do an auxiliary view. So we're going to go UCS object, OB for object, and then pick that face again. And we will center mark that hole. All right, this view is now finished. Again, I'm not going to show any hidden lines in this view. And so this view is finished. That's a through hole, so there's nothing down below. Now, I need to project that hole back into this front view. Okay, so I'm going to draw a line. Again, one of the cool things about using UCS, better than snap rotate, is if I say quadrant, if you were in snap rotate, the quadrant point would be here at the top, here at 90, here at, but because we're in UCS, the quadrant points are rotated to match our cursor. So I can grab that. No, I could grab that intersection also, but nonetheless, this works much better. And then I'll grab this corner, project down, make sure you're snapping at the right angle, and then I'll bring the center mark down. And I'll take it right through the part, like so. All right, I'm going to trim and snip those off. I will shorten this down, like so. And then these go on the hidden layer. And my front view is now complete. And I'm done projecting between these two views. So I'm going to go back to my world coordinate system. That's the default. So I'm going to type UCS, enter. And then you can just hit enter. World is the default, or you can type a W and hit enter. And that gets me back in my world coordinate system. All right, now, over here on this view, we would see that hole as an ellipse. So I'm going to offset 1 inch, like so. Now try and visualize this as you can. Imagine that you were, say, looking straight down on a pop can. And you were looking at the top of the pop can. The top of the pop can would appear as a circle. If you grab that pop can now and you started to tip it over, maybe halfway, and you were looking at the top of the pop can, it would now appear as an ellipse. It would now appear oval. However, the width of the pop can is still the same. It's only, if you will, the height of that circle that has changed. So, when we're on a slanted surface like this, the surface is slanting up and down, that's going to get smaller or thinner. The width is going to stay the same. So what I'm going to do is I'm going to offset half of my diameter, or 0.75, in each direction, because that will be the width of the hole. That should equal this distance right here. However, the top and bottom of the hole are going to be closer together. And I find those by projecting lines from here across and from here across. Okay? Now there's a couple ways that you can resolve this in order to put in the ellipse. One is I can project the center line. That'll help me out. The other is I could trim this box down to a perfect rectangle so I can grab some midpoints. Either one works, and I'll show you while I have all the lines here how to do it this way. So I'm going to come up here to the ellipse tool, and I'm going to do a center ellipse. All right? Because I have the center point. It's right there. Now I'm going to go up and grab that intersection. That sets the height of my ellipse. And then I'm going to come out and grab that intersection, and that sets the width of the ellipse. Okay? So that's one way you could do it. I'll show you another way. Let's take some of these lines out. I don't need the middle lines anymore. And I want just this box, so I'm going to fill it. Excuse me. So that I have a rectangle. And then I'm going to use the ellipse tool and use axis end. And I'm just going to pick midpoints. So I'll go midpoint here to the midpoint here. And for my height, I'll go to the midpoint here. Now I can erase these lines. And we'll delete those. That would be visible, so it would be on the object layer. Now you may be inclined to try to center mark this, however it doesn't work, and for Mr. Randy's class you could leave it open. If your other teacher, Mr. Mann, would like you to show center line, then you could draw a center line across and a center line down. I am missing a hidden line here. I got to get that in. So I'm going to project a line from this corner over. Happens to go right through the middle of that circle pretty much. Oops, I've lost my mouse. That would be on the hidden layer. And then we'll trim that off, like so. Now, if one were so evil as to make you show hidden lines in this part, it takes a little bit of work, but I'd like to show you real quick because it gets at some of the trickiness of auxiliary views. If you look at this hole, notice that the hole pierces the back right there and pierces the bottom right there. So imagine I have part of the circle here and part of the circle here. If you slice a cylinder at an angle, you get an ellipse. And we actually get two pieces of ellipse here. And they would form one tall ellipse. So to get the hidden lines for this, there's going to be an elliptical arc back here that is this tall, right to there. So this gets rather tricky. I'm going to draw a line down. And I'm going to have to extend for the moment. That line. I need that intersection right there. So here we go. I'm going to take a line across. We're just doing this for fun. A line across. And then I'm going to bring my sides down. And I'm going to turn this into a little box. So I'm going to fill it. Like so. Okay. This box defines the ellipse, the top of which would appear back here on the back surface of the part. So we're going to do an ellipse again from the midpoint here to the midpoint here to the midpoint over here. And now we're going to trim. So let's trim from that line, and we'll trim that off. And I'm going to trim these off. I'm going to erase these two lines, and then I'm going to bring these up to here. That's the sides of the hole. And then all this stuff goes on the hidden layer. Like so. So, If someone were evil enough to require you to show hidden lines in an auxiliary view problem like that, that's what it would look like. In the workplace, we would never bother to do that. However, for practice sake, in a 101 class, you might be required to show hidden lines in a view like that. This is not an assignment problem from your 101 class, so you don't have to worry about having to do this, but that's what that view would look like. Okay? And in fact, this would be our finished 3-view drawing. Get that out of the way. Our finished 3-view drawing for this particular auxiliary view would look just like this. Okay? So that's auxiliary view drawing. Again, utilize the UCS enter object feature to project your auxiliary view. Check your view spacing on your handouts. Mr. Mann and I will have defined how far these views should be apart on your auxiliary view problems, mainly in order to keep it easier for us to grade these assignments. And pay attention to hidden lines if they're required or not, to make sure that you get all the information necessary in the views. Okay? Well, good luck. This is auxiliary view, and as always, enjoy.